graph this polynomial function. We're going to, in this exercise, graph this polynomial function at the top. And as always, I invite the viewer to proceed and graph this first, and then play ahead to see if you got it right. If you graph this in any polynomial function, the basic things needed are, one, to get the leading term, and that will be needed to help establish the end behavior of the function. Find the x-intercepts and the multiplicities of those x-intercepts and a y-intercept. So first of all, in establishing the leading term, what we're going to do is multiply all these x's together. And to do that, we're going to have -2 times, we have x squared from this first expression. And then we have this 3x squared. And so all this, when simplified, is going to establish our leading term. And also, there's going to be other things, and then finally the y-intercept. Okay, let's go ahead and continue. When we take -2 times x squared times 3x squared here, we're going to square this 3 to become 9, and 9 times -2 is going to be -18. And then we're going to have x squared times x squared, or x to the 4th. So this establishes that we have an negative at -18, and this 4th power in the leading term means we have an even-natured polynomial function. And for that, what that means, to have negative even, it means we're going to start down here in the 3rd quadrant and finish down here at the lower right corner, the 4th quadrant. Okay, now we're going to find the y-intercept, because that'll be a next logical thing. What we have for our y-intercept is we're going to have, I'm just going to write this below, y-intercept, it's going to equal this -2, and we take the numbers here, and we have times -4, and then finally we have this -2 squared. And what this is, we have -2 times -4 is going to be 8, and this -2 squared is 4, so our y-intercept is going to be 32. And so up here we're going to put ... plus 32. And the last thing we're going to need is the x-intercepts. Well, we have this factored form up here partially, and I'm going to rewrite this below. What we're going to have is the factored form, f of x is equal to -2, and this quantity x squared minus 4 factors in the linear factors, quantity x plus 2 and quantity x minus 2. And then we bring out what we have left, which is 3x minus 2 squared. And for this, we have our zeros. We have, using the zero factor property, x plus 2 is equal to 0. We have x minus 2 is equal to 0. And finally, we have 3x minus 2 is equal to 0. And then solving each of these, we have x is equal to -2, x is equal to 2, and then when we, over here, we're going to add 2 to both sides. We get 3x is equal to 2, and so x is equal to 2/3. Now they're multiplicities of these zeros. Here we have, for x equals -2, we have multiplicity is equal to 1. For x equals 2, we have multiplicity equal to 1. And finally, for x equals 2/3, we have multiplicity equal to 2. And so now we can mark along the x-axis where these things occur. And so we're going to put over here to the left -2, and then to the right we're going to have 2/3, and then we're going to finally have 2, and we're going to mark our y-intercept up here at 32, since we've established that. So now we're going to go ahead and graph this. I'm going to switch colors. So we're starting from down low, and we approach our x-intercept of -2, and we ask ourselves as we touch, is this going to be a even or odd number multiplicity? Well, it's multiplicity of 1. So we're going to go up like this, and we're going to come down here through our y-intercept of 32. And now we're going to approach our multiplicity of 2/3. What is that multiplicity? Is it going to be even or odd? Well, that's an even number multiplicity. So an even number multiplicity will not actually cross the x-axis, but touch the x-axis. And we come back up, and we're going to have a relative maximum here, and we're going to go down again, and we'll approach this final x-intercept of 2. Is that even or odd number multiplicity? Odd number multiplicity. We cross right through. So this is what it looks like. So that's the essence of how to graph a polynomial function. Again, the things needed: the leading term to determine our end behavior, the x-intercepts and the multiplicities, and a y-intercept is helpful as well. I hope this has been helpful to you. Good luck, and thanks for viewing.